Alright, let's go ahead and look over the view now. We're asked for the area of the shape below. The area of the shape below is a rectangle, so we're looking for the area of a rectangle is equal to length times width. We have a length of 1 and a width of 1/2. 1 times 1/2 is going to give me 1/2, which means the area is equal to 0.5. Looking at the next one, we have the area of a triangle. The area of a triangle is equal to 1/2 of the base times the height. Here we have 1/2 times the base is 1/2 times 1. 1/2 times 1/2 is going to give me 1/4 times 1 is equal to 1/4, which is equal to answer choice D. Coming over here, we have the scale drawing is 1 inch. The scale of the drawing is 1 inch to 15 feet. So thinking about this, we want to go ahead and set up a T-chart where this is our original and our actual. This is our X, this is our Y. We know that this is 1 inch to 15 feet, so we know this is just a scale, not a scale factor. It's not 15 times larger, but I can use this scale factor to go ahead and find, it says the length of the longer side, so I actually only need to find the length of the longer side, 1 and 1/2. So my scale factor, y over x, is simple. It's 15 over 1. So y is equal to 15x. And I want to know what, sorry, this should not be 15. I want to know what this is for its y. So I'm going to have y is equal to 15 times 3/2. It's going to give me 45 over 2, which is 22.5. That's answer choice D. And finally, I want to know how many times larger the actual rectangle, how many times larger is the actual rectangle than the drawing in problem 3. So this is asking us how many times larger. That should tell us that we're looking for a scale factor. We have a scale of 1 inch to 15 feet. And in order to have a scale factor and know how many times larger, I need to convert this to all have the same units. 1 inch is equal to how many feet, or how many inches. So I need 15 feet. So there are 12 inches in each foot. So 15 times 12 is going to give me 180 inches. So we know that this is 1 inch is equal to 180 inches. So this is 180 times larger. All right, let's go ahead and flip on over and look at our aim for today. Today's aim is that Kipsters will be able to find the area. Find the area of a scaled figure. All right. So looking at this, we have a scale drawing. We're told that 0.5 inches corresponds to 15 feet of actual length. And we want to know what is the area of the basketball court. So this may be like thinking about, hey, we need to know how much concrete we need to lay for this, or blacktop space, or whatever we need for this particular court. And so what we're going to do is we're going to go ahead and start by finding, we need to find the actual dimensions of the basketball court. And so we're going to start over here with our chart. So this is my drawing X, and this is my actual Y. We know on the drawing 0.5 inches is equal to 15 feet. So I need to find my y over my x. Y over x is 15 over 0.5. And that's going to tell me that my equation here is y is equal to 30x. So now I need to find the real dimensions. We have 2 and 1 2/3. So these are both x values, so to find their corresponding values in the real world, I need to plug them in. Y is equal to 30 times 2. That one's pretty easy, so this is going to be 60 feet in the real world. And for this one, y is equal to 1 2/3. That's going to be 5/3. 30 times 5/3. Which is equal to 10 times, and that's going to be 50. So just a quick sketch, my actual, we know, is going to be 60 feet by 50 feet. We want to find the area of the actual basketball court, so that's going to be area of a rectangle is equal to length times width, which is equal to 50 times 60, and this is going to tell me that this is going to be 3,000 square feet. Okay, moving on over to the next one. Figure below represents a scale drawing of a park. The scale drawing is 2 inches is equivalent to 24 feet in the real world. What is the area of the park? So looking at this, we are going to go ahead and once again set up our cheat chart. This is our drawing x, so our output y is going to be our actual. And again, so we have 2 inches is equivalent to 24 feet, so y over x tells us that our constant of proportionality, or our scale here, is going to be 12. So again, we recognize this is coming out in inches to feet. So that is not going to tell us how many times larger it is, but it does give us an equation we can use to find the actual values. So here I have 8 3/4 and 3 1/2, so 3 1/2 and 8 3/4. So y is equal to, that is 7 over 2 times 12. And that's going to give me 42 feet. And the second value is 8 3/4, so it's going to be 35 over 4. Y is equal to 12 times 35 over 4. And that should give me 105 feet. So again, we're asked to find the area of the park. So the area of a triangle is equal to 1/2 of its base times its height. So the area of this triangle is 1/2 of, let's redraw this really quickly. This one is 105 and this is 42. 1/2 of 105 times 42. I'm going to go ahead and commute this just a little bit because I can find 1/2 of 42 really easily. And that's going to make the multiplication just a little bit faster. 1/2 of 42 is 21 times 105. So now all I have to do is 105 times 21 is 501, 0, 0, carry the 1 is 1. Is 2, is 5, 0, 2, 2, is 2,205 square feet. So we can see that the process here of finding this area is pretty simple. It's just a matter of finding the new dimensions and then going ahead and using those dimensions with the area formula for that shape. All right, go ahead and flip on over to your partner work time. Make sure that you get that done. Pause the video now until you've got that work complete. All right, so looking at this problem, we're told that we have a rectangular room that is 5 by 8. So So just a quick sketch of this is a 5 by 8 room. We're trying to figure out how much area, so we're going to need the area of this rectangle is equal to length times width. But I need the area of the actual room, so our scale is 1/8 to 4.5 feet. So I'm going to have to find the constant of proportionality. This is my drawing, that's my inputs. My outputs are my actuals. And this is 1/8 to, I'll just call it 9/2. So I need y over x. Y over x is 9½ divided by 1/8, which is 9 over 2 times 8 over 1. That's going to give me 36. So y is equal to 36x. We have 5 inches and 8 inches. So y equals 36 times 5. And that's going to give me 180. So as I redraw this, this is 180 feet. And if you did that calculation correctly, this is 51,840 square feet. Alright, so looking at the next one, a tiny microchip that goes into a phone. No picture drawn here, so here's the picture that is supposed to be here. I'll make sure that I told this to you in class. This is 1½ inches by 1 3/4 inches. Alright, so we're looking at this. Now this is where we have to be really careful because I think a lot of us have just gotten into the point. This is a reduction, okay? We're going from a drawing that is 1 inch to a actual that is 1/8 of an inch. So we're actually making this smaller, which means we would expect our constant of proportionality to be less than 1. And sure enough, we see y over x gives me 1/8 over 1, which is just 1/8. So y is equal to 1/8 x. So we know this is 8 times smaller than the original. So I've got 7/4 and I've got 3/2. So 1/8 times 7/4 is going to give me 7/32. So in our actual chip, this is 7/32 inches. And y is equal to 1/8 times 3/2, which is going to give me 3/16. So 7/32 and 3/16. And we need to find the area of the microchip. So that's length times width, since it's a rectangle. 7/32 times 3/16. There's actually no simplification that I can do here beforehand, so I'm going to get that this is equal to 21 over 512 square inches. Alright, the next one, we're given this diagram. We want to find the area of the garden, so we need to find the length and the width first. So we have currently that it is 4 centimeters by 8 centimeters. We're told that our scale here for our drawing x our actual y is 3 centimeters to 20. So we get y over x is equal to 20 over 3. So our equation y is equal to 20 thirds x. And we've got 4 centimeters and 8 centimeters. Y is equal to 20 over 3 times 4. This is going to be 80 thirds, and I'm going to leave this as a fraction because I know I'm going to end up finding the area here in a second. Y is equal to 20 over 3 times 8. Same deal. I'm going to go ahead and leave this as 160 over 3 because I want to find the area of this rectangle, which is length times width. So I'm going to have 80 over 3 times 160 over 3. And that's going to give me 12,800 over 3. All right, and finally, we have a graphic designer who is making this advertisement. We want to know the area of the actual poster. It's 0.75 to 1 is my scale. So this is the drawing x, and we want to know the actuals y, so we can calculate the area of the poster. It's 0.75 to 1. So this gives me 1 over 0.75, which gives me 1.3 repeating, which I actually know is the same thing as 4 thirds. So I'm actually going to leave that as a fraction. Y is equal to 4 thirds times x. All right, what I have to go in here is I have 9/8 and I have 5/4. So y is equal to 4 thirds times 9 over 8. Doing some cross canceling, this is going to leave me with 3. It's going to leave me with 2. So this is y is equal to 3 over 2. And y is equal to 4 thirds times 5 over 4. Cross cancel, this is going to leave me with 5 over 3. So I want to find the area. Area is going to be equal to length times width since it's a rectangle. The length is 3/2 times the width is 5 thirds. Cross cancel. This is going to give me 5 over 2, which is equal to 2.5 square inches. And that's that. So go ahead and move on to your silent and independent work time.